Assalamualaikum and a good day. Firstly, let me introduce our team member. First, me, Muhammad Huzaifah bin Azman. Next is Nur Asma Salsabila binti Muhammad Yunus, Nur Mazli Azrin binti Muhammad Razali, and last one is Nur Syahira Sabrina binti Muhammad Sukri. So we choose to review 5 papers for the application of CNN. So there will be 4 breakdowns, which are the introduction, architecture of CNN, the applications of CNN, and lastly is the conclusions. Okay, for the introduction, CNN is the most commonly used machine learning algorithm specifically for image recognition. CNN can be broken down into 5 processing stages, which are convolution, activation map, max pooling, flattening, and fully connected layer.
Now, let's look into the architecture of CNN. The concept of human neuron connection within the brain and the organization and functionality of the visual cortex is used to construct the CNN architecture. Neurons of CNN are broken into 3-dimensional structure, and each set of neurons examines a small part of the image. CNN consists of 3 main components, which include input, feature extraction, and classification and output. Generally, CNN assumes that the input are image. The neural network analyze and classify image, cluster image by similarity, perform object recognition within a frame. One of the most common cases in CNN used to identify visual data like human faces. Next.
The second component of CNN is feature extraction. The feature extraction component consists of the convolution layer, pooling layer, and nonlinear activation unit, which each of them perform different tasks. Each convolution layer acts upon the pool and rectified feature maps from the preceding layer. Convolutional layer apply a convolution operation to the input. This passes the information on the next layer. Pooling combines the output and of clusters of neuron into a single neuron in the next layer. Fully connected layer connect every neuron in one layer to every neuron in the next layer. The final pool and rectified feature maps are then used as the input of fully connected layer, just like in a fully connected neural network. Okay.
Now let's look into the application of CNN. For this, we have choose 4 examples of application of CNN. First is detection and classification of lung abnormalities. Second, production of super resolution image. Third is doubly injecting object information for event recognition. And lastly is decoding facial recognition. Next. Detection and classification of lung abnormalities. Commonly, radiologists use technology that is known as computer-aided diagnosis, CAD. However, the current technology used are not efficient in detection of lung problem as it is hard to define a particular image due to the complicated image of the lung. So a study made by Kido, Hirano, and Hashimoto in 2018 found that CNN show high performance for the classification of natural image. For the study, 163 and 372 two-dimensional CT image of patients' lung with abnormalities were used. Next. They mark bounding boxes of abnormalization into CT image for training data and used a leave one out method for validation. After completed training process, the results show that diffuse lung disease patterns were well detected. To conclude the study, various kinds of lung abnormalities can be discovered and differentiated with CADX that use CNN and CADE that use rCNN. Next.
The second application of CNN is production of super resolution image. Super resolution is the process of recovering a high resolution image from a given low resolution image. Instead of directly reconstructing HR image frame by frame, This approach below only synthesizes changing pages. Firstly, group the page into altered page or unaltered page. As you can see, in the frame T plus 1, there is a red region with a size of 16 times 16 pixel. That is a target region which would like to be matched in the frame T. There are 3 steps search algorithm. First, calculate mean squared error for 9 directions. Secondly, start the matching process at the top left region and set the step size of 4 pixels. Third, use the smallest of 9 mean square error value to set the direction for the search process and repeat the process until the target is matched. Next. SR reconstruction process. The low resolution image acts as input. Then the first frame reconstructs the high resolution image. The frame T plus 1 contains the altering pages, unmatching pages for the low resolution frame T. Subsequently, the high resolution page are reconstructed for the unmatching pages via CNN to get the high resolution image for the frame. Then, the high resolution pages for the matching pages were acquired from the previous frame.
Okay. So the third one is doubly injecting object information for event recognition. So for this application, it is for event recognition. As we know, certain parties require event recognition to increase or improve the work quality. So when it comes to event recognition, DoD CNN is very useful as it is an object recognition because recognize related objects for a particular event to boost the accuracy on an event recognition. DoD CNN is inspired by IoD CNN, where it is a continued version of IoD CNN. As illustrated in figure 6, IoD CNN is an improved architecture where it combines 3 networks: event recognition, rigid object recognition, and non-rigid object recognition. These networks share the initial layers for each task, but for the DoD CNN, the output feature is extracted from the intermediate layers for multiple regions of interest, ROIs. Integration among a number of feature maps with the number classification probabilities, ROI sampler will form a single map using the batch pooling. Sharing certain weights among detection approaches may boost the result of the detection. As for this situation, object recognition has boosted the result for event recognition and not among those by sharing weights among those architectures, it will boost the accuracy even more. As we know, weights are important in training CNN to perform a more precise output. DoD CNN clearly proves that weights do play a big role in playing for CNN architecture.
The fourth application of CNN is decoding facial recognition. Facial recognition is important for authentication, especially in security applications. It is widely used in a modern society, for example, in access control for home security and mobile phone unlocking. In the CNN architecture, the addition of a recursive method can enhance the feature of an image, and it allows the CNN to automatically extract the image features to make the features more obvious, which result to a better identification accuracy. The proposed method aims to improve the accuracy of real-time facial expression recognition. The method is divided into 3 steps. The first step is obtain and input the image to the CNN architecture for recognition. Second one, obtain the result of facial expression recognition. And the last one is average the recognition result with the previous output and re-output. The detection can be programmed, for example, in Python on the Anaconda platform to achieve a detection rate of about 10 images per second. This step was followed by grayscale conversion and resizing for each image to immediately and quickly input the captured image into the trained framework. For example, we can use data of 7 expressions. and the dataset will be input into CNN architecture with parameter of Python and TensorFlow for the training architecture on the Anaconda platform. The figure shows the architecture of CNN in facial recognition. As shown in the figure, the architecture is divided into an input layer, 3 layers of convolution and pooling, and fully connected layer for obtaining the prediction result of 7 expressions. The first layer of convolution uses a 5 times 5 convolution kernel, while the second convolution layer uses the same size of kernel, and the third convolution layer uses a smaller one. Max pooling is employed for the pooling of each layer. To obtain the result, we need to do sufficient number of training iterations of the above architecture. The final result is derived from the average of the current recognition result and the previous recognition result, because the system considers both of the CNN architecture and the influence of the environment of the captured image. Each image has 7 weights indicating 7 different expressions, which are recorded and averaged with the weight of the previous image. Subsequently, the largest output is therefore regarded as the prediction result. It is worth noting that the proposed average weighting method is used when the weights are produced from the second identification. Because the weights are averaged between the current and the prior recognition, the error is accordingly reduced. The accuracy of the original CNN architecture complement each other to enhance the overall performance. Next.
In a nutshell, convolutional neural network is an algorithm that takes image as input, analyze and classify image, cluster image by similarities, perform object recognition within a frame. The application of CNN that are notable are detection and classification of lung abnormalities, production of super resolution image, doubly injecting object information for event recognition, and decoding facial recognition. There is more potential in CNN that is undiscovered yet. Thank you.